Hello, Math 2 Extended. This is a Unit 1, Lesson 2. We're going to be talking about exponent rules. So in class, we worked through this exploration for the video. We are just going to skip that. So an exponent applies to the number or variable that is immediately to the left of it. This number or variable is called the base, and exponents are just showing repeat multiplication. So x squared really just means x multiplied by x, and 5 to the third really just means 5 times 5 times 5. An exponent applies to a group only if there is a grouping symbol to designate that combination base. So these two expressions, a -4 squared and the quantity -4 squared, those are different things. If we were thinking about our exponent rules, the 4 is repeat multiplied. So this is -4 times 4. So that's -16. This is -4 multiplied by itself. So this is positive 16. So make sure you're really being conscious of what the base is. In this case, the 4 is the base. And in this case, because we have that grouping symbol right here, the -4 is the base. Oops, sorry. Okay, so, and then over here, these two expressions are different. 7x squared is different than 7x quantity being squared. So in this case, the exponent is right next to the x, and that exponent only applies to the x. So 7x squared, is 7x squared. We can't really write it any differently. But if we have 7x squared, that means 7x multiplied by 7x. So this is actually equal to 49x squared. So you can think of that power of 2 as applying to the 7 and applying to the x. That's where we get the 49. But just make sure in order to do that, the grouping symbol has to be next to the squared. And that tells us that the power applies to the 7 and the x. So here are some properties of exponents when we have multiple exponents in an expression. We might want to be able to combine them into a more simple form. So if you have two separate bases, so we have base A here and base A here, and they each have an exponent, we can add together those powers. So this is because exponents are just showing repeat multiplication. So x squared times x to the 7th is x to the 9th, because 2 plus 7 is 9. And that's just because x squared is 2 factors of x to the 7th is 7 factors of x, and so what we have all together are 9 factors of x. So again, you can just add those exponents together. So 2 plus 7 gives you 9. If you have an exponential expression that is raised to an additional power, like a to the m to the nth power, that's when you can multiply those powers together. So w squared to the 4th really just means that we have, really just means that we have w squared times w squared times w squared 4 times. And each of those w squareds is really just 2 factors of w being multiplied together. So what we have is w to the 8th. So you can get that 8th power directly by doing 2 times 4. So we add if they have their own bases. We're just counting out the number of factors. And if we have a power raised to another power, we multiply. This last rule tells us what to do if we have a more complicated base. If we have a more complicated base, like a number times a variable or two different variables together, then we want to apply that power to each of them. And this is really because of the commutativity of multiplication. So if we have -3x and that's being squared, we can think of this as a -3 being squared and an x being squared. So -3 squared gives us +9. So this is +9x squared. So we applied the power to the base the portion of the base that's the coefficient, the -3, and we applied that power to the x as well. Sometimes you'll have problems that are kind of a fusion of those two rules. For example, if we had a 7x squared raised to the third power, we would want to use this rule where we apply that third power to both parts of the base. But then we would also have this rule where we could multiply together those powers here. So our final answer would be a sixth power, and then 7 to the third is 343. So watch out for situations where you have, two rules that you need to apply. So multiplication is commutative. I kind of talked about this a second ago, and this property can help us simplify more complicated expressions. Like if we were asked the product of 3x squared and 7x, the fact that multiplication is commutative lets us sort of rearrange that to get a simplified answer. So what it means that when we say multiplication is commutative, it means that the order that any two things get multiplied in is unimportant. 5 times 3 is the same as 3 times 5. So if I have 3 times x times 7 times x, I can rearrange it into 3 times 7, which is 21, and then all of those factors of x can be combined into an x to the third. So if it asks what's the product of 5x and 9x, we can think about multiplying those coefficients together and then think about how many powers of x do we have. So this would be 45x squared. Now we often don't write this step out. We just usually do this step like in our head. We think about which things we can multiply together to simplify our expression. But we would normally just do that step in our head and kind of look at this first line and directly just write down our answer. No need to show that middle step. I just want to show why that works and what we're doing. So in lesson 1, we talked about combining terms when possible. So for example, 9x plus 2x, those are two terms that we can combine. 5x squared plus x, we can't combine those two terms, so it would just stay as is. When it comes to applying exponent rules to find products, though, we're always able to multiply two little expressions together. So we can, in this case, multiply 9x by 2x to get 18x squared. So those two answers that we got when we add 9x and 2x together, or when we times 9x and 2x together, those are very different answer. When we're adding those terms together, the exponent doesn't change. We're just counting up how many x's do we have. We had 9, we add 2 more, we've got 11. When we're multiplying monomials together like this, we are going to see powers that change. So 9x times 2x gives us 18x squared. We weren't able to combine 5x plus x with addition, so we just have those two separate terms, but we certainly can times them together. When we times them together, we get 5x to the third power. Very different answers for similar problems, so you really have to pay attention to what operation you're doing on each problem. All right, so we have a little mixed practice here. So an expression like this looks very complicated. And unfortunately, sometimes our brains like to group things that aren't grouped. So right now there's no parentheses here. But sometimes when people see this 5x minus x, they want to combine it. But what you really need to think about is the terms in the expression. Remember, terms are separated by addition or subtraction. So in this case, I have a minus sign right here, and I have a plus sign right here. So this expression really has three terms. We've got a term right here, a second term right here, and a third term right here. So really look for those addition and subtraction symbols to help you separate terms. Remember when we talk about in earlier grades, PEMDAS, I think is how the teachers say it. Multiplication occurs before addition and subtraction. And so we need to multiply these two little monomials together to simplify this term first before we can think about whether or not we can add the terms together. So 4x squared times 5x gives us 20x to the third power. We want to subtract the next term. X times 8x is 8x squared. And we want to add the last term, 2 times x times 7x is 14x squared. So looking at that list of terms now, you can see that the first term is different or unlike the others. So it's going to stand alone in our final answer, 20x to the third. But the other two terms are both squared terms, so we can combine those together to give us a positive 6x squared. So look for and identify your terms, how many terms you have first, simplify those terms, and then look for terms that are alike to combine. So that is it for this lesson. There are some practice problems in your notes that we practiced in class, so I'm going to go ahead and go forward and show you those answers. If you want to try them, you probably should try them on your own first, and then the assignment is also in your packet. So if you were absent in class, try to work on that assignment and turn it in as soon as you can. Here are the answers to the additional practice problems that are in your notes. If you have any questions on any of these, let me know. If you still need to look at those, go ahead and pause your video. I'm going to go to the next screen. And there's the last little set. These are very challenging. So if you find that you aren't understanding where one of these answers comes from, please let me know. I'd love to talk to you about it. All right, that's it. I do have a bonus assignment available for this lesson. If you're interested in the bonus assignment, let me know and I'll give you a copy of it. It's going to be due before test day, so if you are interested in the bonus assignment, you got to let me know ASAP. Thank you.